Sorry, copy and paste.
It's
No.
I look like I'm here, but it's Thursday, so I'm remote.
What, you mean you haven't got your coffee yet?
Jen explains to me this is a copy and paste error, and if she not copied and pasted the slides, they would be in Comic Sans, so I'm happy to remain remote.
You know, like, I have no problem with that. We might lose some audience. I did. I have them approved by PR team. I have a slide there approved by PR team. In Comic Sans. Yeah, I can create it. So, I don't think we shall really write. Yeah. Good morning. Please wake up if you haven't yet. It's a path-aware networking group, and we have quite a busy agenda, so I think we shall start right now. Welcome. This is a node well, and Brian just pointed out it's a wrong one. I have an action item to fix it for Montreal. Sorry, but I don't know what the difference is actually.
So yeah, the IRTF basically follows the IETF's policies, but I think there's a different slide for the IRTF. It's the same. Actually, Dave, you're looking at like which do you use for map? Okay. Anyway, we'll have a look at this, but yeah, do note well the IPR actually in the IRTF you don't necessarily have to disclose it if it moves into the IETF. You do, but you should anyway. So. We'll fix this for next time.
Yeah, and thanks Aaron for being a JavaScript, but we still need a minute taker. And unfortunately, we cannot proceed until we find one.
Tommy. Hi, Tommy.
Hi.
How you doing?
Yes.
Yes, sir.
That's what I get for walking in.
Thank you very much.
You can back up, Tommy. It's a pretty easy job backing up for Tommy.
Right.
Okay, cool. Thanks, Dave.
Thanks. So agenda, it's been published on the website. Any like comments, changes, complaints? 3, 2, 1, sold. Yeah, so we have 2 active group documents, and we have individual drafts which we discussed last meeting and going to discuss today as well. And I think we have 1 new individual draft. And I think that's it. So we can start with the first presentation, which I guess is Spencer. I'll get a slide. So if I do this, and then I do this, right? Yeah. Yes, it's a clicker.
Clicker clicks. It's the first time I've been here. First time before.
So good morning, everybody. I feel really good this morning because the weight of all my dots went away yesterday. So life is good. So I'm talking about the obstacles to deployment draft that we've had in the research group for a while. This is update what happened in -01, and what I really want to do is figure out how to use this draft after we agree what we need to do with it next. So anyway. Gori provided contributions on ST and ST2 and things like that, ST2 plus, ICMP source quench, and on IPv6 flow labels. And he also performed a significant review of the -00 draft. Thank you, Gori, for that. I think I've addressed all of his comments, and that's what went into -01. This included a significant rewrite of Section 2, the summary of lessons learned, which is kind of the point of doing this draft. So I want to get that right. That's what I want to focus on during this talk. So not at the wordsmithing level. We have a mailing list in GitHub for that, but this is the "Are You Out of Your Mind" review by the research group, and following up on that in email after the meeting. So this usually when I've talked about this draft in previous Panrg meetings, I've presented a summary of lessons learned. This is the unsummarized version. This is actual text that's in the draft. Don't want to, like I said, don't want to wordsmith this, but want to give people an opportunity to say that's not right. That would be an interesting comment. And another really interesting comment would be that's not, that used to be true, but it's not anymore. That's going to be something that's going to be really important for us to push down on. If we're using this material to guide research and to guide the IETF as they are trying to engineer path-aware networking. So first one, I can just put these up and let people look at them, or do I need to? Should I actually say something out loud?
I would say something out loud.
Okay, cool.
Do you want to discuss each one, or do you want to?
Yeah, yes. I want to stop on each slide and let people say that's not right, or that used to be right, but it's not right anymore. That's the review and evaluation I'm hoping to get as a result of this meeting from the research group. So first one, overcoming entropy for already employed devices. So the benefit of path awareness must be great enough to overcome entropy for already deployed devices. We say, if it ain't broke, don't fix it. That turned out to be best current practice on today's internet. And there are several contributions that pointed to this one. Do we kind of think this is still true? Are you guys humming each one of these, or?
No, we're not going to hum.
Okay, cool. Okay, so nobody dive for the microphone. Providing benefits for early adopters can be key. If everyone has to deploy a technology in order for the technology to provide benefits, or even to work at all, the technology is unlikely to be adopted. Again, a couple of contributions that have pointed this direction. Do we think that that's true? And do we think that's still true?
Jake Holland. Hello? Okay. Yeah, Jake Holland. Let me say, I think it could use a little refining. So maybe if you want feedback on this, maybe I should open a thread on the list. Is that the recommended thing? You don't want wordsmithing here.
Yeah, wordsmithing on the.
Yeah.
Yes, wordsmithing on the list, please. Sanity check. Is this insane?
So sanity check, I'd qualify it, is kind of what I'm looking at. There's benefits and there's like pain of adoption, right? So easing pain of adoption can mitigate the cost. So I just would say maybe that point feels to me like it should be here, and I don't think it is.
Let me. So it's the audio is actually kind of crap up here at the front. Let me restate this to see if I heard you correctly and see if I can rephrase that slightly. So this is phrased entirely in terms of benefits, so the plus side of the equation, and you're talking about cost reduction, which would be the minus side of the equation. That should be captured here.
Yeah.
Okay. That's good feedback. Thanks.
Thank you. I think the contributions that we kind of taken that out of. So actually, here's the other part of this, which is if there's things that are missing or subtleties that are being totally stomped on, like the one you just mentioned, it is helpful for us to point to case studies, that would tell you about that. I was mostly thinking about this in terms of early adopter things. I think the classic one was like what can you do? What can you do with a new version of HTTP and things like that? Or a new version of TCP? Do receivers have to do anything in order for people using this to get benefits and things like that? But most of those have not been about costs. So it would be helpful if you can drop a note to the mailing list, especially, you just say a technology that points this direction for cost would be whatever it is, and we can follow up from that. Is that fair? Okay, cool. Thank you. Yeah.
Eric Klein, is this the same or different from single mover benefits? In other words, where one party can unilaterally take some action and get some benefit versus two parties taking action, both of them get a benefit, as opposed to all parties having to take action, which I think.
I think the idea on this one was basically, does everybody along a path have to do something? So so you had the thing where it's like, well, if you were deploying a new technology and some of the boxes along a path support it and some of them don't, do you still get benefits? Does it still work? That's what I thought we were kind of pushing on in section 4.2 and 4.3.
Okay, so that could include single mover benefits. It depends on what's being on the particular. Right, thank you.
So, I mean, the other thing is, I've gotten up here and done the summary of the summary a few times, but these are the words that are actually in the draft, which is like the new level of specificity, as we're talking with the research group. So, thank you. Cool. So if you have end-to-end mechanisms that work well enough, and this is something that has been over and over and over again in TCP. That's not the only place it's been. You could do some new cool mechanism, but if you're going to catch up in a couple of round trip times anyway, was it worth doing? And the section that I contributed where my idea failed was one of those. And, it's like, we're not saying it's a bad idea. It was also a bad idea, but we're not saying it was a bad idea. The problem was that a TCP that didn't support what we were talking about could catch up in 2 or 3 round trips anyway. So if you were talking about making the TCP state machine more complex, but you're going to catch up in a couple of round trips anyway, then it's really not, there's not really not something that is pushing the deployment of that technology. Does that make sense? Cool. Okay, Corey, you're diving for the mic? Cool.
Gordon Fairhurst, just to talk back to you a little bit. Yeah, the fun thing about these things is if that's the only one on the list that really matters, then you probably shouldn't do it. But it might be worth doing that, providing your system was really robust and there was no side effects. A little benefit, but for some people that might be a huge benefit. So then you've got to weigh out all the other things. And I think that's the tricky bit of the whole game.
Yeah.
So it's really good to call out these individual things, but sometimes a combination of them is what matters.
So a high-level thing that I think I'm hearing here is that if you look at this whole section, that's very interesting. But when we look at individual bullets in this section, there's like, well, some of them may interact with each other. Some of them may. And I think the other thing that I'm kind of thinking as I'm standing here is that there may be some of these that are going to be impediments to deployment, and some things that are going to be just absolute fatal. If you try to do this, you should be arrested, and your technology can never be deployed. So I think that providing that kind of background and an explanation at the beginning of section 2 is going to be, I think it's a really good suggestion. Thank you. And Gory's made a large number of excellent suggestions throughout this draft. So there goes another one. Thank you, Ori. The follow the money one. And this basically was saying if you can't charge for a path-aware technology to recover the cost of deploying it, then the benefits to the operator have to be really significant. And I think this is kind of pushing on our previous conversation, which is sometimes we're talking about benefits and sometimes we're talking about costs. So if if I can't charge for this, but it reduced my operating expenses by 30%, I'm still interested. But so those are two of these considerations that kind of interact. So I think that's kind of where that's pushing. Are you all diving for the mic or just diving for chairs? They're diving for chairs. Laura's, on the other hand, maybe diving for a mic.
Like the corollary to what you have up there, right? So if the operators want to charge for path-aware networking, it better be useful for the customers, right? Because somebody has to pay for it, and it will be the customers in that case. And when they externalize those costs, they better be worth it.
Cool, thank you. I suspect that we may end up with enough of these kind of comments to justify adding a section that kind of an entire section that kind of explains the relationship between these things that we've learned and kind of, which ones seem to dominate, which ones seem to interact. So yes, that one also.
Hi, Aaron Falk. I think this one and the first one that Jake commented on, I think these are really sort of variations of the same thing, right? It's that the parties that bear the greatest cost have to get some benefit, right? And that whether that's operators or users or end system vendors or whatever it is. But the thing that occurs to me, I'm trying to dig out the citation, but the data tracker is really slow. Is the IB did this draft on incentives for protocol deployment, and I think these are the same themes here. And so maybe the thing to do is to incorporate that by reference.
So a question here. There were a couple of IB drafts on that. There was 51 mumble, what makes for a successful protocol, and then there's planning for protocol transition to 8170. Are you referring to one or both of those?
Well, I think in terms of the incentives aspect, it's going to. I would be very surprised if the message in those was different, but I haven't read them recently, so I can't answer your question.
Yeah, so 8170 goes a little bit more into the incentive stuff, and I don't remember the first one.
My point being is that there's nothing special about this from the point of deployability, and so I don't think that we need to reinvent that part. That maybe the thing to do is to just cite that and talk about the things that are unique about the path-specific piece.
So I think that take a look at one of the 1.something sections that actually call out 2 or 3 IAB drafts in that space and say, this is general guidance, not particularly path-aware networking advice and guidance, but general guidance. And like I say, see if I've handled that correctly, or if there's still some things I need to fix there.
The text that you're putting up here seems very general.
Yeah. Well, so the reason it's very general is if we dive down into section 4, where you're going contribution by contribution, then that gets a lot more specific. But this was basically saying, what do we learn from multiple? What have we learned? Not from any particular contribution, but what have we learned? And so you'll see most of these. I would say at least certainly many of these, but most of these have come up on multiple contributions. So like this one's come up on at least 3. So this is not obvious on the slides, but the section numbers here are section numbers in section 4, subsection numbers in section 4, which is specific contributions on specific technologies. So this has come up at least 3 times. So yeah, this is general. The more specific ones happen in section 4, and it would be actually good to say that out loud also. Thank you.
Let me interject as chair here. Let me rephrase what Aaron is saying as like a more direct piece of advice. Maybe is have a look at this draft and consider what is special about path awareness and the transitions that we're talking about here, as opposed to other transitions, and maybe call that out. I think, as somebody who watched this draft progress, the process that we had here was, go look at what failed and then try to pull commonalities out of what failed. So at this point in the exercise, what we're seeing is that many of the things that we can take from the history of failures in transport line up very nicely with what we've taken from the history of success and failures in other areas, right? Which is what those other documents, the DIAB documents, were a little bit less transport focused just because of who was contributing to it. So I think that in and of itself is an interesting signal, and one that we shouldn't just attenuate just because it makes the document a little bit less verbose. But I would reiterate the point that, yeah, we should maybe be a lot more explicit about what's special about path-aware networking here, because a lot of these are general, but I think we get into more specifics, not just in section 4, but also toward the bottom of this list, which we should probably move through a little faster.
Yeah, and just one nit about the document itself, that to call this a bestiary of roads not taken, I think these are actually roads that were taken that we regret.
So these are roads that were not deployed, taken, but they were definitely taken, and we regret them.
Tim Chan. So I think this one, and maybe the second point you make, where you talked about it requires the operator to enable something end-to-end. Maybe you can tease it out by looking at those mechanisms where just one or both end systems need to do something where it's incrementally deployable, which is point 2, versus things where the operator has to actually enable something end-to-end, like this, versus perhaps there's a third one, maybe more, where the mechanism requires something to work end-to-end that an operator might not enable. In fact, they might filter it, like extension headers, for example. Mm-hmm. So there's different perspectives depending on what type of mechanism it is. And you talk about 8 points, and it's very difficult, as Aaron said, to make generic statements when there's so many different approaches. I think that's the problem. Whether teasing it out to different categories of approaches might help. I don't know. If you're thinking of building something that's just host systems, here's some points. If you're requiring operator enablement, here's some points.
Yeah, cool, thank you. So the point about operational practices being showstoppers, that if a path-aware technology requires changes to operational practices, that can prevent deployment of a technology that would be otherwise promising. Nobody diving for the mic on that one. That one may not surprise anybody. Someone is diving for the mic? Hi.
Colin Perkins as an individual can prevent certainly, but doesn't mean will prevent.
Yeah, and I think that that's the kind of thing that we need to do, with the tension between ideas that are fatal and ideas that can be deployed if other considerations point the other direction to making deployment a good idea. Thank you. Per connection state, and this is one that has come up in conversations within the last 18 hours in the spherical router session. But basically, dating back to the land of like INTSERV, we have always known at some level that per connection state in intermediate devices was going to be a problem. So that was what was being captured here, and I really want to get a sense, either here or on the mailing list or both, whether people think that they can do this now, where we couldn't do it before. Yeah, I mean, there were a lot of things we wanted to do before that we just couldn't do. So could we do them now if they were the right thing to do? I think I see at least a couple of people lining up who are per connection state kind of people. Hi, Stuart.
Hi. So it depends.
Okay, yeah.
It depends very much. At the edge of the network, you've got a lot more power. You've got devices that can touch more of the packet and can do things, and we have an existence proof with NAT and gateways and stuff. In the core of the network, it is really, really hard. All right, you can see the packet. You don't even see those counters that you increment, right? You sort of ping a thing off somewhere, and some piece of hardware changes a piece of RAM that you can't even get to. So per connection state is something that's tripped us up a few times. An example is trying to do in deterministic networking, trying to figure out whether you've seen another instance of this packet before on a different interface. Almost impossible to get it between interfaces. Then there are other examples when we've tried to instrument the network, where we've had to go to special technologies in MPLS in order to find out when a flow actually stopped, because the packets from different flows, or a flow group rather, different flows may go different ways across the network. So it depends on where you are and what speed you want to do it at.
I am thrilled that we don't seem to be conflicting with the same routing sessions that we've conflicted with in the past. Welcome.
Hi, Brian Trammell, as an individual, not a routing area person, and I'm going to rephrase the same thing with different words, and yes, but no. So the increase in scale of the devices that you could be able to maybe push some per connection state from the edge a little bit closer to the core is also driven by the increase in bandwidth and the increase in number of flows. One really interesting thing that we might see with the deployment of QUIC is when you multiplex a lot of flows into a single flow, each endpoint might be responsible for fewer network visible connections than it was in the past. So these numbers are all going to keep changing, but they're going to keep changing in such a way that I don't think there'll be any significant change to where the boundary is between where you can and where you can't. It's going to keep sloshing back and forth. It always has, and it always will.
Yeah, and if I could actually ask you to stop there, but change hats for you and Jen, this is kind of what I've been doing here has been about trying to identify principles. And one of the things that happens when you go from section 4 to section 2 is that you're less subtle in section 2 than you were when you were talking about a specific technology. So if it looks like that may be pushing not the right direction, I would look for the chairs and the research group to guide me in the right direction. This being a research group draft and all that.
Tim Chang. So I was very impressed with the 2 sessions we've had on quantum internet and the QIRG. One thing that they did present there, which made me think, was that to actually move quantum state from A to B, where you have multiple quantum repeaters, you need to do entanglement swapping, and you need to have a parallel classic internet data path between all the quantum nodes over which other bits are sent. But they're also having per quantum node state to do that, and an RSVP-like protocol. So maybe that's the only way they think they can do that. But I guess the question is, if that's a future technology and they think they need per connection state, is there advice beyond this where you can say, well, if you must do this, then, or are you indicating that approach is perhaps doomed to failure? How do you advise a new research group or a new activity like that? How do they draw on this advice to actually make sure that what they're trying to build has the best chance of success? I think is the question.
Right. So if I had any dots, which is a problem that I had that went away late last night, if I had any dots, I would be thinking in terms of this document being mostly about our experiences, and maybe another document that points to this one but provides guidance so that you don't have to drag. Gory contributed stuff on ST, which was back when we were trying to decide, whether we were going to run everything over IP or whether we were going to have other protocols at that layer that behave different from IP along the same path. So I mean, like that goes along. Do people have to slog through all of that to figure out what to do now? And so that's kind of what I think we need to tell people what they need to care about now. And my question is that in this document or is that in a follow-on document that points to this one?
Yeah, Tim Jones, yes, I think you're absolutely right there. It's a question of doing it.
Cool. Thank you.
Stuart Bryant again. So the other thing that needs to come out here is there's a difference between per connection state imposed by the control plane and per connection state imposed as a result of a data packet passing through. We have existence proof that, providing you persuade the operator to deploy it, that things like RSVP is a good example of per connection state that was imposed in the control plane and then just used as the packets went past.
So I want to say this one here is my last slide. I need to go back, but this one here's my last slide. And we're talking about, we've been getting stuff, a lot of stuff from transport. A lot of the stuff that came in this round of updates was from ANT, but going to the routing and forwarding part of the community to see what their experience has been. And I think, I was hoping that we were ready to do that and that would be a useful thing to do. And I think you're kind of telling me that it is. Yeah. And I appreciate that very much.
You might want to take this to RTGWG, would be a good way of getting a cross-section of the routing specialists.
Thank you. All clues are graciously accepted.
Hi. Colin Perkins as an individual. I think Tim makes an interesting point in that we're making assumptions about the underlying architecture. This is what is difficult to deploy, assuming an architecture that looks like the current internet. It may be interesting, and whether that's for this document or a different document, to discuss somewhere to what extent changes to the architecture may affect these assumptions.
Yeah.
Quantum is a pretty radical change, but it's certainly not the only one we're considering with things like ICN, for example.
Thank you.
Jake Holland, as some of the comments on this point in particular have shown, I think there's a general comment for many of the points on this list, which is there are examples of some protocols that sort of were successful and violated the advice here, right? Might be also useful to call them out and say, these are counterexamples to this thing. Here's what's different about them. Because I think that's going to be, like, the advice to do none of these things is going to be really hard to follow for path-aware stuff. But the advice of, like, here's the difference between ones that worked and ones that didn't, look at them and draw conclusions is maybe more useful.
So the thing where the IRTF does not produce BCPs, I think is really helpful, which is basically we're saying here is guidance. You should consider the guidance. You should figure out how much of it is applicable to you versus how much of it is applicable to other things which are not what you're trying to do. And that you would, of course, do the right thing because making good choices is what we're all about. I have a T-shirt, right?
So, Gary Fairhurst at a possibility of arguing with myself, but agreeing with Stuart. I mean, I was thinking that in TSBWG we just got an email talking about how you might want to do per flow accounting of things to work out about overload and fairness or congestion collapse prevention. So per connection state is something interesting that's not necessarily to do with the forwarding decision. So you might want that, but it doesn't stop forwarding. And I guess that's somehow linked to what Stuart was saying about control plane and how you use it, etc. So maybe we need to capture that a bit. But that was a comment. My question was, how does all this fit in with the path-aware routing or path-aware forwarding when you have devices on the path that have state and other ones don't have state? I think that's something where you might find something radically different when your path-aware networking says do this, and suddenly you end up with a different set of boxes on the path because some of them are smart to state.
Yeah, I think if I'm understanding you, you're basically saying that there's a tension between canonical bad ideas and but you got to do it anyway in order to make this work. So what it's going to take for you to make it work? Why is this not going to be another contribution in this draft of things that don't work? What changed? What did you do differently? Maybe you put per connection state in a different place in the network. That's a reasonable strategy.
And that's cool, and it might be soft state for another reason. But then when you have some path-aware thing that's trying to pick two paths, you might get some of these boxes on one path and some of these boxes not on the other path. And now your path-aware networking, if we think about doing this as a big solution, there's another level of issue here because the boxes aren't all the same that you choose.
So if we have not just tripped over, I was going to say, if we have not just tripped over stuff for the research questions draft, I'd be disappointed.
Yeah, I think this is a really interesting conversation because it actually is showing that we're trying to decompose this problem. We're being analysts about it with these two different drafts. But when you're actually trying to think about, well, how could we build something different in this space? That's not a fundamentally analytical task, right? So so part of the outcome of this discussion is maybe we need to think about, again, how these two overlap and what the next steps are. But that's not this discussion. I will note that we have 20 more minutes for this discussion and 7 more slides to get through on questions, and they do get much more detailed as we go down. They get much more path-aware networking-y. So I'd ask, I'm going to cut the lines with the two of you and ask you to be brief.
And ask other people to send stuff to the list.
Rüdiger Geib, Deutsche Telekom. We are running an MPLS backbone, and network separation by MPLS is actually a security feature too, and you might want to add that to your list. That opening that to outsiders is for us breaking our security. And path tracing in an MPLS network is probably possible. It requires some additional features, but path predetermination, well, I'm not aware of how you would do that without installing state prior to the first packet arriving. So it would be great if this work group is not just creating a problem for others in the network, but also figuring out how to solve it. Because as soon as you start to imbalance the load on the backbone, you start to imbalance the economic calculation of our network.
Cool. This was the one you were pointing me to?
What he said, but what I came up here to also say, is that it depends on whether you're talking about base or an overlay. So you can do what you like in your own overlay, providing you deploy it. And before people say, well, overlays are bad, you realize that you're almost certainly running on an overlay when you're running in base, because the transport network in the sense the ITU uses it, they're running a hierarchical network underneath. It's just that you don't see it.
Cool. So like I said, just kind of blowing through where we are. Am I diving for my last slide yet?
No, you skipped one though.
Yeah. I think I skipped a couple. Yeah, that one. Yeah, this one. We talked about this a lot. I mean, we talked about this for 2 hours in the spherical router session yesterday afternoon. So we're not going to have that conversation again here because it took 2 hours the last time. But just awareness of this, and like I say, we're pushing on this in other venues as well. So definitely having that conversation, which I owe the community. I will owe the community minutes from that session also yesterday. So I will try to remember to point Panrg to that output for y'all to have that to consider. But basically just, if we're doing things that are going to drop you off the fast path forwarding, people are going to want to talk to you. These two, and I am thinking that I want to phrase these differently than I did in the past, the more I look at these slides, but I kept trying to combine network paths trusting endpoints and endpoints trusting the network path. I kept trying to combine those, but those really are two different, very, very different kinds of considerations. And for us to be very aware of those. This is something that we've talked a lot about in the transport area over the past probably 3 or 4 years. Certainly we've had a lot of conversations that were guided by the IEB in that space also. So just like I say, just an awareness of both of those, and that they're both, they both matter and they're not the same. Trust in each direction. Providing actionable information, and this was basically the ones where I've told you something about the network path that was not on a hop that you're close to, and it was long enough ago to where the situation could have changed at the location that I'm telling you about. So basically making sure that we're not trying to react to things that may not be true anymore. And that's been a couple of things that's come up with different technologies. Then the question about, do endpoints know what the path needs to know? And this actually turns out to be two different things. One is that applications may not know what the path needs in order to help the application. And the other is that the endpoint may not be using an API that that allows the application, which might know that information, but the API that the application is using doesn't allow you to provide that information to the network path anyway. And this is kind of where we are with the TAPS working group in the IETF, and then exploring how policy interacts with what applications know and what applications can tell the path, and what policy is going to be guiding what the path does. That set of interactions is something that's important for us to keep in mind. Nobody diving for the mics? Okay, so assuming this has gone well enough for us to put up this slide, what other experiences should we capture to add to lessons, to add additional lessons learned? I was a little bit surprised that we were able to put in 3 new contribution sections in section 4 for ST, for source quench, and for flow labels. But what we were learning from them was different. We were adding lessons learned to the section 2 as a result of those new contributions. So that kind of told me that I wasn't finished yet. So, what else do we need to capture? And recognizing that we started out with a really transport-heavy set of contributions, and that we've been adding things in the int space, and that we talking about reaching out to routing space. And I think one of the things I was getting from discussion around Stuart's comments were that reaching out to routing may be next. So one of the things that all document authors are interested about is how far do we have to go before declaring victory with this document. So I'd like for the research group to be thinking about that. How much time do we have? For me, I mean. Another 10 minutes. Okay, great. So let me stop there and ask if people have thoughts about the other experiences we might capture.
So I'm going to jump in as chair first real quick.
Please.
So while people are getting to the mic on that question, so we keep talking about reaching out to routing. So some of this is a little bit the chair's fault for not being more forceful in trying to deconflict this with things that were interesting to routing people. It took us about 3 iterations to get our conflicts list correct.
So we've only met about 5 times.
Stuart had suggested going to routing working group. I would say maybe post a pointer to that list, and would that be something that we should get on the agenda for Montreal? I see you in line, so.
I'm not the chair of the working group. I mean, obviously.
But you go there and I don't. So.
Yeah. I would have thought.
Okay, cool. So we should, take those on as action items
Yeah.
for Stuart.
And
Spencer.
sorry.
Take those on as action items for Spencer. So
Yeah.
I was looking at Stuart and
Yeah.
looking at you and got the names wrong.
Almost
There was
everyone who has ever gotten my name wrong has guessed that it was Stuart. We're clones. We're just not very good clones. So thank you for that. And the other thing is, now that I don't have to cover transport area working groups all the time, I have a lot more flexibility to go do things like that now too. So this is something that we can do, I think, better in the future than we've done in the past.
So there is another driver that you need to be aware of, well, I'm sure people are aware of, and that's network slicing. Because network slicing does require state in the network to support applications because of the extremity of latency property, for example, and bandwidth property and isolation that they're looking for. That's one thing. Second thing is, I think there's a big difference between a random application being deployed somewhere and requesting stuff from the network, and an application owned by sort of a mega corporation that needs certain properties asking for it, because the contractual relationship, the money is kind of different. And what we're seeing is a world in which actually the application kind of owns almost its entire existence. A good paper that really brought home to me what the internet looks like now is the work that Jeff Houston's been doing on death of transit. And I really recommend that people read that to understand that the internet is not quite as we teach it in school.
So could you drop a note to the, I'm aware of that work, but not everybody in here may be. Could you just drop a note to the mailing list with a pointer to that? I appreciate it a bunch.
Tim Chang, my first suggestion is simply that I was going to make a point about the fifth point in your list. Perhaps number the points so it's easier to refer to the points, because at the moment they're bullet points. Just might be a good thing. The point I was going to make is which of the points that you've made would cover just the general problem of network ossification? Is it 0.5? Looking through them all, it seems that 0.5 is the one that would generally capture that general problem.
Yeah, I think, like I say, I think one of the things I'm carrying away from this, I started thinking about this like this morning before this session started, but I'm really taking this away from the comments that have been made, that we need to do a better, I keep going back and forth between we and I, so Gory and I have manipulated most of the text that's in there, but it is a research group to have, so somewhere between I and we need to do a better, need to add context around our summary of lessons learned and say, say those kinds of things in there and do a better job of explaining how to use them now that we've got them, explaining how to use them. So, yeah, thank you.
Yeah, and I think also the point you made earlier about the quantum internet, RG, their stuff, I guess their best avenue is to get review from routing area and things like that. But I think in general, it's some kind of guidance. I know we can't do BCP here, but for example, if you take segment routing, which I don't think is mentioned in the document, maybe the path hasn't been determined as a good or bad path yet, no pun intended. Maybe to look at that if you're thinking of deploying that in your network for a specific purpose, as an operator I'm involved with is, how much of that can we draw, or how do we draw from this document, how do we benefit from this document?
And just to say this out loud, so if you want to do a BCP in the RFC series, you kind of have to do that in the IETF stream. But the IETF stream controllers, the ISG, can decide that something that was done somewhere else is a really good idea, and they're going to strongly encourage people to do that. The IEB does good work that isn't BCPs either anymore. So, that's a possibility, not that we would tell the IETF what to do, because that always ends badly, but that the ISG could say that those are good ideas, this is a good idea, and we're going to be kind of looking to see if people are aware of it when we're chartering work and when we're evaluating work. So, like I say, I'm not telling you that we can tell people what to do, but I'm telling you that somebody can tell people what to do, and we might be able to provide guidance to those people.
Hi, Colin Perkins. On your last bullet point, I think perhaps filtering is not really the right way of phrasing this. If participants, people who have been involved in this group wish to go to some of the IETF working groups and participate in the design work going on in those working groups and apply some of the ideas they've learned from this group in that design, I think that's a very good thing. So we're clearly not here to descend on the working groups from on high and say the Panrg view on how you should design your protocol is.
Cool, thank you. And it is definitely true that different IRTF research groups have different styles of interacting with IETF working groups. If you think about what the transport area gets out of ICCRG, or what the entire community gets out of Crypto Forum Research Group, there are different models that we can definitely be looking at on how this research group might want to be used.
Rüdiger Geib again. Try to figure out maybe what is the real requirement. Because if I hear that network should be sliced and then the argument is we need the path with the shortest delay, then that seems to be the requirement, the shortest delay. But I don't understand the rest of the slicing. You can have a VRF, of course, and your own labels, right? But you don't need a path in the network. But then also figure out, if this path with the shortest delay is broken, would you like to get a backup path? It will not have the same delay. Now, if you would like to have a backup path with a different delay, which might be longer, and you can cope with that, I wouldn't understand why there shouldn't be load balancing from the start and you use both. Thank you.
I think I am agreeing in thinking that is an excellent point for follow-on work. Basically,
what we're trying to do here.
This is kind of what the research group is chartered to do. So definitely. When are you all going to tell me to stand down? Huh? Excellent. So my last thing was basically how long do we need to continue to iterate on this type of draft in this research group, and I will defer to the glorious chairs for thoughts about that. Thank you all.
So first, I'm actually curious. Could you please raise your hand if you read the last revision of the draft? Well, yeah, some people doesn't. Yeah, but I think it's a great job. So I strongly recommend you to read this if you haven't done it yet. Right? If you are in this room, I assume you're kind of interested, unless you're just looking for a place to read your emails. It's not the best one to call here.
I would say that, so your third point here, go to routing, follow the path into the routing area, make sure that people there are aware of this, and see if they can also come up with, various train wrecks from the past to learn from. And then, we can have this discussion again in Montreal. I'm assuming that we'll try to get on the agenda for routing working group in Montreal. So it might be, after that meeting that we pull that in. But it seems like it should stay open until then, at least. Thank you.
Thank you. And the next presentation. We don't have any slide. Great, Brian.
I like coming up and giving a talk about, for which I have no slides, with assuming all this has gone well so far. It's a good slide to give my talk to. Basically I just wanted to come up and ask, as the author of Open Questions in Path-Aware Networking, this document, thank you. This is going to expire in a few weeks. I think we've had good discussion about this document at many of the previous Panrg meetings. Have been on the agenda I think each of these. Each time we've iterated on it, we've gotten good input. I've brought it into the document. I think that we're kind of done with this one. And I would like to ask the research group, sort of as the editor of this document, just my editor hat on, what we want to do with it. Do we want to leave it open, or do we want to publish it as an IRTF RFC? I personally lean toward publishing this as an IRTF RFC simply because I'd like to have a thing to point to in other fora when they're like path-aware networking, what is that? And it's like, well, this is the set of questions that we're looking at. So I'd like to have this as a snapshot in time, and maybe we could add some language to it at the front that says, this is not the end-all be-all of the questions in this space, but this is a snapshot as of here. So people who don't understand that RFCs are immutable can read that and understand the nature of it. So I'd just like to have a quick conversation about the room's feelings on that.
Spencer Dawkins, am I?
Yeah, you got to eat that one. This one's hot, that one's cold.
Okay, I have to be retrained. So Spencer Dawkins, and I think that's brilliant. The one suggestion I was going to make, and I think that's on the bottom of my last slide was, is it worth looking at what we've learned and what we think the research questions are, and saying, are there additional research questions that we really need to solve in order to do the kinds of things that we want to do? That was the only suggestion that I had for any additional work on this draft, and I think publishing that is brilliant. And I'm hoping to be able to publish the what not to do draft, in something like the same time frame.
Okay, so I'll take that as I or we should sit down and compare notes sometime before the 20th of April on this one, just so we don't have to watch it expire. Yeah.
Moi, look at the orange. So I think this is really a good document because it tries to formulate the problems and what are I would say the critical point to be addressed for providing something which is really but aware. But I really don't think that it is timely to force this document now and to publish as an RFC. I think that's the pointer is there, so you can just point to the current version of the draft so that people may be aware of what is currently, I would say, discussed here in this working. But I think it's really too early to declare for this one. Let it open more and see more feedback from the candidate for this one.
Okay. Do you have feedback? You're not committing to send me. I mean, so you like it and it's good, and there's nothing you want to change.
No, I can see two comments.
Yeah. Okay. Yeah, that'd be great. Thanks.
Hi, Jake Holland. I like the idea of publishing a snapshot. I think it's a good idea. My problem when I read this draft is that I ended up feeling, okay, so what? And I wish there was just a little bit of actionable suggestion in there. Panrg is looking for documents that address some or all of these questions, for example. I don't know if there's other actionable things that could be mentioned, but that would be a good one.
So you want a section 3, so what?
Yeah.
Okay. That's actually, yeah, I'll see what I can do with that. Thank you.
Mia Kulevin? Maybe it's the AD speaking out of me, but why do you need to publish it as an RFC? Just keep it as a living document and you can update and look at it and talk about it.
Okay. I mean, so it's just, you as an AD speaking, this would not actually come onto your desk other than through conflict review, so you don't have to do any work for it. But yeah.
That's great. But the question is also, does it have an archival value for people reading it later on, or is it more important for you as a group to have it written down and look at it, right?
I think that
I don't know what the answer is.
I think my main reason for wanting to do this is to have something that is archival to talk about this in fora outside the IETF and the IRTF. It's really to answer the question of, but I mean, I can just as easily send a data tracker link to the document in progress as I can an RFC. That's fine.
Kirsty P, NCSC. So I like that you're capturing the problem space here, and you keep saying it's a snapshot, and it's not credibly clear to me from reading it that this is just a snapshot, and that you do expect for it to change over time and for the problem space to evolve. So that's just a comment that's not incredibly clear to me from reading it. And it might be obvious that you publish it will be updated, but perhaps you calling it open questions, and it could just be some open questions or something to suggest that this is not the entire problem space, but just a part that you want to focus on initially.
Yep. Thanks.
Jake again. Mary's comment made me wonder. I think that my reason for thinking it's useful to make a snapshot is that I expect these to be open for some time to come. If it's going to be a relatively short timeline, like 5 to 10 years, and we think it'll be kind of solved, then yeah, maybe just keeping a draft alive is that long. But if it's going to be more like 20, then I think the RFC might be useful in an update later if they change or something,
Thank you for the optimism on the timeline. Okay, thanks a lot for the feedback on this. I have what I need as editor. I would just personal curiosity. Who has read this or the previous version of this draft? So since IRTF. Okay, that's order a dozen. Cool. Thank you very much. And we go on to the next now, yeah?
Yeah, thank you. So you have some action items
I have
now.
some action items.
Perfect. So next.
So, hi everyone, my name is Cyril, and Teresa Enghardt and me wrote a second revision of our draft that we presented at the last Panrg, vocabulary of path properties. And we tried to incorporate as much feedback as we got from you as possible. So we did 3 major changes. The first one is we added a section called terminology, where we describe all the relevant terms which we use in this document. I will quickly go through of all the definitions we made. So first we have a path element, which is either a device or a link on which a packet can be sent or forwarded or sent over. Then we have a path segment, which is an ordered set of such path elements at the network layer. And finally, we have a path, which is simply a path element with the first and last path segment with the first and last element being an endpoint. Then we have a flow, which is a set of packets traversing the same path elements. Yes?
Yeah, just one clarification question for the previous slide, please.
Yes?
I think that's, I have already one problem from the first bullet. So if we just define a path element as a device, then we lose all the visibility on the service functions that are embedded in the path device itself. So the path is not only decomposed of, I would say, devices, but it is, I would say, a sequence of service functions that are invoked in that path. So I would like to have something which is more visible. If, for instance, if you are talking about multipathing, for instance, multipathing, we did with that with a given service function, which is, I would say, we call that converter in PTCP and this kind of work. So we need to have this kind of visibility and the definition of the path. So it is not to be specific only to hardware and device node themselves.
So I guess the idea is to kind of define a path, and then we can still describe stuff that is more on a lower level or on a higher level. But that's I think that's the thinking we had, that we define it as a network layer on a device level. Then you can still describe stuff within one device. So different functions within a device, if I understood your comment correctly.
Yeah, actually, what I'd like to say is that we need to generalize the old definition of the path, which is only the consequence of the ordered sequence of nodes to an ordered sequence of service functions. The service function may be collocated with a given device or may be embedded in various ones. So we need to zoom a little bit on this, I would say, the device itself to enter into this sequence of the service functions. Some of the path awareness functions will be provided by the service functions and not visible to, I would say, to the aggregate device that will host these functions themselves. So we need this visibility somewhere if we want to provide additional functions to the endpoint and to the applications. So we need this exposition somewhere. And if we start to define the path, it's only at the level of the device, I am afraid that we will lose this visibility. So that's why I'm raising this point here.
Stuart, Brian, have you checked that your path segment definition doesn't conflict with the segment as the Spring Working Group are defining it? There's a major project to do segment routing in the IETF, and an alarm bell rings in case there's a conflict of definition.
To be honest, I'm not too familiar with the Spring Working Group, so we chose path segments as it kind of describes it, but I'm not sure what exactly the definition of the Spring path segment is, so I would need to look that up.
Yeah, I mean, they're really well advanced, and they have the concept of creating a path through an ordered set of segments.
Yeah, okay.
I think like a while ago at some other meeting of this group, I commented on sort of my disappointment with the lack of formalism, and it's still there. Even on this slide, right? You don't differentiate what is a device and what's a link. Reading this, you allow a path segment that consists of only of links and no devices, or only of devices but no links. You said it's an ordered set. What is it ordered by? Is it a total ordering? Is it over what time scale? Right. So it's good to see that you try to be formal, but what you have is so limited and at the same time so ambiguous that I don't think it's useful. So already with these very basic definitions, there's so much just incorrect and also ambiguous that I don't think it's not productive to really discuss much more.
So this is only kind of a summary. I just
I looked at the draft. It doesn't say anything more than that.
Yeah.
So what's the difference between a device and a link?
I guess
it's one or the other, right?
Yeah, on a link it's just about forwarding. On a device it has a certain function in addition to forwarding.
What about links that connect more than one device or more than two devices?
So again, links
links can connect more than two devices, right?
Yeah.
So it seems that you try to be formal, which is great. Some of this has probably been done elsewhere for part of the problem, but I think you need to be, if you want to define a terminology, you need to be way more rigorous than you currently are.
Yeah.
Okay, so I'll cut the line with the people who are standing there already. So,
just a comment, Joachim Fabini. There is substantial overlapping between this work and what has been done in the IPPM. So we have RFC 2330 that defines all of these hubs, links, and so on, class seed, type P, some properties that are very, very related to what is defined here. We have the root draft that is commonly a working group item in IPPM that also defines the root and subpaths and so on. So, and in a much more formal way, I'd suggest to see and capture commonalities and perhaps define a common document. I don't know.
So we did look at the IPPM work, and we kind of we got inspired by it to use, or it was part of our inspiration to use this kind of having an ordered set of device and links. But yeah, we can.
Yes,
Line
something more about it.
Hi, Jake Holland. I just want to disagree with a couple of the prior commenters. I'm looking at the draft, and to me, it looks like there is a nuanced and expressive, not to say it could not be improved, but that some of the comments presented previously have already been addressed by the current text of the draft, in my opinion.
So you really need to read, I think, RFC 8402, which defines segment routing architecture, because I do see a huge overlap here. And for people who wonder why you might want to specify device or link, what segment routing does is to have the concept of strict and loose routing. And to do loose, you go to a device. To go strict, you go to through a link. So you may specify a set of links you want to go through, or you may want to specify a set of devices, or you may want to specify both, depending on exactly what you're trying to achieve. But this really does need to align with a piece of work that's been going on for 5 years over in the main IETF.
Okay, thanks for the comments.
So, chair question for Stuart, if you could get back up. So I'm like passingly aware of the work in Spring. I mean, I know what it is, but I haven't looked too deeply into the architecture. In your opinion, as somebody who spent some time on that, is the architecture of that generalizable so that we could talk about path properties in a way that is not tied to the segment routing header and how it's implemented in Spring? Yeah, you don't have to answer that question now, but I'd like you to think about it.
Yeah, I think I do need to think about it. Because there's also the other body of work which specifies path, which is what RSVP-TE has been doing, which is another way of specifying paths.
Well, IPPM has done it as well, right? And, you know, I chair IPPM, and I actually didn't say that they should have a look at that because I think of that primarily as paths as measured as opposed to paths as constructed.
So remember, the thing about Spring is that they construct the path and then they put the path in the packet, as opposed to putting the path in the control plane or specifying it some other way. I'm not sure whether it would be directly applicable, but we certainly need to make sure that we don't have a clash of terminology.
Absolutely, but if I could ask you to have a look at that, think about it, and maybe come back with a paragraph on.
Yeah, I've got to.
Yeah, that'd be great.
Pick your drafts up and read them.
Gori first. I suggest it may be useful for the working group to do what Stuart says before we start ratting on the individual terms in here, because terminology is always hard, but getting the base terminology right is really cool.
Thank you. That was a useful violation of Mike-line protocol.
Okay, so after the definition of flow, we actually define a property, which is a tuple which consists of the name of the property, for example, whether it's a maximum data rate or a latency, the value of this property, and the path segment which it's defined on, and the flow which it's defined on. So it's possible to define a property only on a path segment and not on a flow. For example, if we look at MTU, it doesn't depend on an actual packet being sent, but if we look at the latency or the queuing state of the network, then we also need to incorporate the flow, so the packet being sent. And we can aggregate properties. So essentially, aggregation is simply a function from a set of properties to a single property. Example of this could be a numerical aggregation, such as minimum, or a logical aggregation, which says if this property exists for any of the path elements or path segments, then it's valid for the path itself. And then we can distinguish between measured and potential properties, where a measured property describes an actual measurement, and the potential property is an estimation of a property value at a certain point in time. And it's important to note that if you have a potential property, you need to have some notion of certainty. If it's in the future, you might say, I don't know what will happen between now and the future if you only infer this property from another measured property. You also need to say that there's some error margin for this potential property. And the second big change was we added 3 use cases. This was due to a comment which said it's not clear why we chose the path properties that we described. So how did we reach to this selection? And in order for this, we described 3 use cases of path-aware network, or within a path-aware network. The first one are traffic policies. Example could be an endpoint which does not want to synchronize large amounts of data over volume-based cost, path with volume-based cost model. Then we have network monitoring, where a network operator can measure path properties to see if a certain quality of service is achieved. Okay. And then we have path selection either from the network perspective or endpoint perspective. Maybe it's important that endpoint selection is similar to Alto, which provides a better and random peer selection. So there, path awareness is also relevant. And then we did some changes to our path properties. For example, we took some low-level properties such as wireless, single strength modulation rate, channel utilization, and changed it to the more generic current and maximum data rate, which is also used in the dynamic link exchange protocol. And we did some. Okay.
Yeah, so sorry, we kind of running out of time. So I think based on the feedback, I think it's maybe too early to talk about adoption because I think you have some action item to address.
Sure.
And sorry, yeah, we don't have time for questions, but I appreciate if people will send their comments and suggestions to the list. So sorry, we just kind of.
And we hope to see you back in Montreal on this one. So thanks a lot. Keep up the work, but I think you got a lot of feedback about, a little bit more homework that needs to be done on this one.
Perfect. Thanks a lot.
Thank you very much.
Sorry, if you can do it slightly quicker than 10 minutes, that would be appreciated.
Okay. Sure. Okay. So yes, I'm going to make it quick. Hello, everyone. Pleasure to be here. My name is Stefan. I'm presenting to you some use cases that we do have for security based on the Panrg work, which is more or less multipath routing. Well, the anonymized black guy here, that you see over there, could have been pretty much me the last time I was trying to get an SMIME certificate into my mail client. So I was desperate in sending an encrypted email, and of course asymmetric crypto is cool, and we do it in research and we teach it at the university, but it still is computationally heavy, it's computationally difficult, it's cumbersome, it's expensive, and eventually my problem was settled with a tactical knockout in the 10th round. After an hour, the mail client convinced me just to not use SMIME anymore, so I ended up sending an password protected zip file, because I simply couldn't get it to accept the SMIME certificate. So, and I'm even a security person. So what I'm looking for is usable security. And even more than 10 years ago, we already came up with the idea that perfect CIA plus security, which means confidentiality, integrity, availability, plus authenticity, is actually doable using only symmetric crypto. That originated from quantum network security, actually. We figured that it applies in any kind of network. There's no need for quantum here. So we're using only point-to-point shared secrets. We can do it without certificates, so it's cheap. We can do it fast because it's computationally lightweight if it's only using symmetric crypto. And most importantly, we can use it doing it without much involvement of the user, which I find personally nice because I don't want to bother and deal with any certificates. I just want to have this as a secure connection. So the idea is using multipath transmission, in which I can choose paths at random to rely on a network sending my packet from me to my destination along any path that I can choose deliberately as far as I like it. And this is what brings me to Panrg, to the path-aware routing, because we do rely on the network's ability to give me paths that I can choose from. And even on the theory side, we can trade computational complexity and tractability for this certain network topological and service features. So the idea is actually multipath routing, which means that I'm trying to send my message over a couple of paths, hoping that there is at least some sort of positive probability that the adversary wouldn't catch all the packets. So as long as there is at least one of these paths not being intercepted by the adversary, I have a chance to get my message through with arbitrary strong security. I don't need to have any end-to-end shared secrets here. This is what we call in theory a moving target defense. It's actually a matter of research in game theoretic security, which is in parallel to the classical crypto. So after all, we ended up with some use cases or requirements for the use case of using path-aware routing for perfect security without much certificates and public key crypto. We need to know a number of paths. We need to know the path elements in any way they might be defined now or later. And we need some sort of reliability of the packet to stay on that path. So we're actually counting on the network to deliver the packet on the way that we chose. And that goes into the draft as requirements 3.1 and 3.2 in the sections. And also we need to rely on this to be able to work in cross-domain. So if there's two network domains, that we can come up with ways to connect the two so that the properties of the network are preserved in a way that still enables security. So we can run the protocols on the application layer as long as we do have full awareness of the path, as long as the networks are joined in a way that those properties of the underlying bit graphs are preserved. That's very easy. And the requirements are actually stated in the section 3.3 until 3.5. And finally, as on the crypto side, because we do some encryption here, but not on the application layer, it's much deeper below that, we require some device pairing to be enforced, by which I mean, of course, I'm sorry for the fuzzy terminology here. Devices just means whichever node actively sends something to another node should do so encrypted. It should be paired in the sense of sharing keys with that further node and refreshing them. So that would be requirement 3.6. And well, actually, that's it.
Thank you very much. Okay, one quick question and we'll go to the last talk because we're really running out of time.
This is again Rüdiger back. Did you check possibilities of address entropy? Because if you start to use different addresses and maybe just the sender address, then the flows will be routed differently within a single domain in almost all backbones that I am aware of. And the interdomain case, you need to apply tunnels to get to different AS paths. You should investigate that, I think. That's much simpler than what you propose.
Okay, thanks for the suggestion.
Thank you very much. I think you posted it to the list, right? The draft.
Yes,
yeah,
I think
okay, so
okay.
Comments are appreciated.
Simon, come on up. We're sorry, we've got about 8 minutes for your 15. So, yeah, we'd appreciate going quickly. Thanks.
Okay, so hello, my name is Simon, and in my talk I will talk about how game theory can help us to reason about the efficiency of path-aware networking architectures and to eventually help us to make them more efficient. So the terminology I use here is about source-based path selection, and what I mean by this is basically a path-aware networking architecture where an ISP offers its customers, so the end hosts, a set of possible paths to a destination, and the end host can then choose for themselves which path to use for communication. This is in contrast to network-based path selection, where basically one single path is offered by the network operator as a result of BGP. So whenever we discuss these two paradigms and their relative efficiency, we will always encounter basically the following opinion. So in general, network operators like network-based path selection because for them it means that they can engineer and coordinate and orchestrate traffic very well. So since they have a lot of experience, a lot of information about their network, they can basically guarantee an overall efficient traffic outcome. So it's to use this analogy, it's like by the skill of a good conductor that the music of individual musicians will become a nice symphony. It's by the skill of the network operator that individual flows can be fit into an overall efficient traffic allocation. In contrast to that, source-based path selection is viewed as something like that. So network operators fear that if end hosts choose their own path through the network, basically anarchy and chaos will break out. So without the appropriate information and without coordination, end hosts will take bad traffic allocation decisions. They will engage in mutually destructive behavior. And so the nice, efficient traffic allocation will give rise to a much more inefficient traffic allocation. And so the question I'm interested in is how justified is this fear? Or put more technically, how inefficient is the traffic allocation that we can expect to result from selfish end-host decisions? And as kind of constructive follow-up question, whether we can reduce this inefficiency by providing the appropriate information. In order to tackle these questions, we need to have a way to quantify the inefficiency that results from selfish decisions, and we need to be able to capture the effect that information has on this efficiency. And we can do this by a game theoretic concept called the price of anarchy, where we need a social cost function that captures the social cost of a traffic allocation, and a way to characterize social optima, so traffic allocations which minimize the social cost, and Nash equilibria, so traffic allocations where no single agent will unilaterally deviate and change its traffic allocation. So these are like stable states in a network. And once we have these three components, we can derive this price of anarchy. For that, we need to have a model of source-based path selection, which is here presented for the interdomain context. So you have the autonomous systems, or ASs in blue, and links, inter-AS links, alpha, beta, and gamma. Every end host, every AS can accommodate end hosts. For example, here AS A1 accommodates E1 and so on. And every end host has a demand towards other end hosts in the network. So for example, this is this vector D. So end host E1 has a demand of 1 towards end host E2, and end host E3 has a demand of 1 towards end host E4. Then this vector large F here describes how the demand is split between all the possible paths between these origin destination pairs. And so it describes how much traffic there is on every path. From that, we can compute this vector small f here, which is a link flow pattern, which describes how much traffic there is on every link. And so furthermore, links have cost functions, and they describe the queuing or latency behavior of the link. And in general, the larger the link flow, the larger link cost, and as a result, we can also compute this path cost here, which is just the cost of all the links in the path. Then we can derive the social cost function, one for end hosts and one for network operators. The time doesn't allow me to go more into how these are justified. But apart from that, we're also interested in, like this, we can characterize the social optima, but we are also interested in the path flow pattern that results from the selfish behavior of end hosts, so the Nash equilibria. And of course, the information that an end host has is very relevant for its behavior. So we need to have a notion of the information that an end host has. And one classic way to formalize the information is latency-only information, where an end host knows all the costs of the paths to a destination. For example, here, the end host E1 has a demand of 1 towards end host E2. It has 2 available paths, and it knows the cost of both of these paths. And in this network, it turns out the cost of both paths are equal. And if we have a situation like that, the end host will actually have no reason to change its traffic allocation. So this is what we mean by an equilibrium. But this equilibrium here is dependent on the assumption of latency-only information. So when we have a different information assumption, we will get a different equilibrium. And for example, this is the assumption of perfect information, where an end host does not only know the cost of all the paths, but also what the link cost function, so how the link reacts to latency, which is linear and constant here, and also the background traffic, so the traffic not originating from itself, which is 1 here on both the links. And with this knowledge, an end host can set up such a selfish cost function. It can minimize the selfish cost function. When this optimal allocation is reached, an end host will have no reason to change its traffic allocation because all the other traffic allocations will mean a higher cost. So this is also an equilibrium, but it's a different equilibrium than we've seen before because the cost function is different. So what we see here is that we can take different information assumptions. We can compute different equilibria from that. From this equilibria, we can compute different prices of anarchy. And when we compare this price of anarchy, we get such a difference, a delta, which captures the effect that information has. With this framework, we can gain a number of interesting results. For example, we can see that the end host optimum and the network operator can be quite different. We can bound the price of anarchy above, given certain assumptions on the latency functions. We can prove that additional information can be beneficial to network performance, but that it can actually harmful. So it may be but had to provide more information. Okay. And as a last thing, we also see that additional information becomes irrelevant with the scale of the network. So for example, internet, it might not make such a big difference whether you have the latency only information or the perfect information that we have seen. So with this, I'm at the end of my talk.
Thank you.
Yes.
It was
Okay.
awesome. Time-wise,
Yeah.
it was good talk and
Okay.
perfect long time. So I'm afraid we don't have time for questions, but again,
We don't have time for questions, but I'm the chair, so I get to ask a question. I'm going to do two. So first of all, this is really interesting to give a little bit more of a formalism for, I forget the numbers of the questions, but there's two questions that this talks about, like with respect to interest, and how with respect to stability, right? Like, so exactly the question you used. This is one of the open questions in the draft that we're considering here. Is this work that you would be interested in pursuing further in this research group?
That's one reason why I'm here. I just wanted also to find out whether this is of any interest to you, or what would I have to change to make this of any interest to you? So
Can I see a show of hands of people who understood this and find it to be interesting to the problems that we have? Okay, yeah, I see. I think if there's interest in the room, definitely. There's more interest in the room than read any of the drafts, which is even cooler. So I think that's your answer is there interest? There's definitely interest. I think, if you can take this up, put it in an internet draft, send it to the list, and we can discuss from there. That would be great.
Okay, thank you.
Thank you very much.
Yeah.
who has not signed the blue sheet? Everyone. Perfect. Thank you. See you in Montreal.
I'm hanging out. I'll be in Git for the first couple of minutes. Hello. This is that was, hold on a second,